In this video, we're going to have a look at unit testing. So testing is an important part of the development cycle of any project. Its purpose is to verify that what was created behaves as it was designed to, and also to identify any potential defects. So in programming, these defects might include errors, warnings, algorithm mistakes, and other functional mistakes. So the main goal of testing is to eliminate defects in software before they become much larger problems to your end users. With the modularization of coding, a defect in one small component could have a wide-ranging effect throughout the actual application. There are three main software testing types. So we have unit testing, integration testing, UI or end-to-end testing. So unit testing looks at testing small individual parts such as functions or components and classes. These errors can be removed before the function or component is integrated into a larger system, and these tests can be automated. Integration testing looks at how components of a program behave together. Individual items might work fine on their own, but have some unforeseen issues when used in conjunction with other parts of the code. These tests can also be automated. UI or E2E, end-to-end testing, normally involves a series of test scenarios and outcomes that focus on if an action happens correctly rather than how it did it. If the unit testing and integration testings work and the desired outcome of a scenario is reached, then we can have greater confidence in the abilities of the application. These tests are much harder to automate. After functions or components and classes are integrated into a larger system, errors and bugs become much harder to track down and fix. So to avoid this problem, smaller parts of self-contained code should be tested. Unit testing is the process of testing individual functions or components and classes to remove as many errors or bugs before they are integrated into the larger system. So a unit test should return either a pass or fail. There are no degrees of a pass. It can't pass a bit. It either passes everything or it fails. The unit test should be run in isolation from other dependencies. So any required values should be stubbed or mocked. So if we've got a service that's requiring something from a database, we can mock the information coming from the database rather than relying on an actual database existing. So why do we unit test? So unit tests allows programmers to validate those smallest parts of their code so that they work and behave as expected. We ensure that any changes made to those smallest parts don't result in a change to the expected behavior. And we can ensure that if any changes are made to the smallest parts of the program, that no new errors or issues are introduced. So a caveat, so something that makes a test fail. So writing a poor test can still let errors through that you might not expect. So planning for unit tests. So identifying the requirements for a new function class requirement. So we need to be looking at what was the expected behavior, what were the types of inputs, what was the expected outputs, any required try-catch, so error checking conditions required, and what are the expected fail cases where the function is not suitable for use. We need to design a test case or test cases, write some test code, then we write our functions or class or component to meet the needs of that test code. Then we need to perform our test to ensure that any new functions behave correctly. So we look at, is it chicken or egg? Do we build our test and then code, or do we write the code and then build a test to check that what we built was okay? That leads us to the concept of test-driven development. So in essence, what we want to do with test-driven development is to write a single unit test describing an aspect of our program. We should run that test once, and obviously it will fail because the code does not yet exist. Then what we want to do is write just enough code to make that test pass. Once it passes, then we're done and we can move on. It does also, once again, rely on the test being rigorous enough to cover all necessary requirements, yet it doesn't want to be over rigorous that you're testing stuff that doesn't need to be tested. So one downside of this test-driven development is it does have a higher effort required for initial development. So it's not something that you might be able to get in there and quickly write a bit of code and get it going. Well, now you have to sit and write a test case, or design the test case, write the test case before you even start writing code. So it does have that higher effort. But on larger projects, you'll find that in the long run, there will be a reduction in effort in the final phases of the project because you will have tested these things. You'll have more assurance on how good they are. So the number of errors you might pick up at the final phases of a project should be less, which should make up for some of the effort that you would have put in up front. So testing a functional component or class with a single test with only one set of inputs and one expected output is not capable of eliminating unforeseen bugs or issues. So test cases are a set of tests for a single function, component or class that puts it through a series of different scenarios to ensure that the function, component or class works correctly in different conditions. So these scenarios are otherwise known as test cases. So a single test case contains a set of, so you would have the function or component or class being tested. There will be a description of the test case, the input used in the test case, and the expected outcome of the component or class being tested. So in this particular example, we've got a list of our tests, one checking for missing input, one for bad input, and one that would trigger the validation. And we might have multiples of these. This is just a short list. So if we're looking to see, we're trying to add two numbers together, our first input here is testing to see whether both inputs are there. We have, obviously in this one here, they've said there is a default for the second number, so even if it's missing, is not a problem. And the test will pass because we get our resultant number is good. If we have bad input, so we're putting in a number and a string, then we still get it good. The answer is good using JavaScript that will automatically try and convert the type of a string to a number, in which case it will cast it to an integer of 2, and so all is good. We might have an option where someone's putting an input through that is not a number at all, in which case we should be throwing some error back to the user saying you should be entering a number. So integration testing, so the next step on from unit testing. So methods, functions, and classes may work correctly on their own, but however may have unforeseen issues or bugs when used in conjunction with other parts of the code base. Integration tests are designed to test how well several methods, functions, and classes behave together. So integration tests are used to make sure that changes to components or modules don't adversely affect the rest of the program. The most common use of integration testing in web development is testing of controller functions and API calls. So why integration tests? So integration tests have three main benefits. As they're based off functional requirements, they can be used to verify if the functional requirements match the final product that's created. They also help ensure that changes made to the code base don't introduce any new bugs or errors. And they're also capable of finding issues that subcomponents have when they interact with each other. Unit tests can only test functions. They can't really test how different functions work together. And that's where the integration tests come. So integration tests are normally much larger than a unit test and can have a number of extra stages. So a single test case within an integration test may have to set up a database with specific entries. So this is our idea of stubbing or mocking. So we may have to mock up a database with a set number of items so that our integration test can work. We may need to test what happens when there is nothing in the database. What happens when we have one person in the database? What happens when we have duplicates of people in the database? So we need to create those scenarios in the database first before we can test them. And that's part of the integration testing process. Here we just got some examples of some integration tests and their test cases. So if we're missing an input on the client create API, so it should then trigger some input validation. So data requirements, we had no data required. Input data, we needed a name, an age, and a state. Expected output was a JSON, which should return the name field. The data cleanup requirements, no cleanup required. So in our integration tests, we have these setup and cleanup requirements, which is to stub in or to mock in information that we might need in the database, and then to be able to repeat the test, you may need to then delete those bits out of the database, set it back up as it was again, so the next time you run the test, it works again. So with these integration testings, there is a setup and cleanup requirement for each of the tests potentially. So planning integration tests. So we want to define all our functional requirements. For each functional requirement, a new set of test cases are created with a new function. For each of the tests, create several test cases. So you should have a test case to make sure that we have the correct data is going in. We want to make sure that any validation of that data is done properly. We want to make sure that the data that is returned from that case is the right one. And we also want to test each of the different try-catch, any of the different error tests that we may have in our code to make sure that they handle it right and provide the right feedback. For each test case, identify any test data requirements and any cleanup activities required so that the next test will work correctly. We'll then write our test code, write our code. So this is following the test-driven design methodology. And then we run our test to ensure that the written code works as expected. So the mean stack, this is what we're working from, which is Mongo, Express, Angular, and Node stack, has automated test tools. So running tests manually is a very long and boring and expensive process. So automating these tests using these testing frameworks provide a way to quickly test our code and reduce the possibility of human error. So Node.js has many testing frameworks. So listed here are some of the more popular ones of Espresso, Mocha, one which we will be using, Intern, Vows, Node Unit, JS Unit, Node Tap. Angular itself built in uses Jasmine and Karma as a task runner. So the mean stack uses Mocha as its unit testing framework. So to install Mocha, so before we get to installing Mocha, it's important to discuss why we shouldn't install this as a global dependency. So testing frameworks change over time and as such should be added to projects as a developer dependency. It's better to install testing frameworks this way so that changes or revisions to the framework don't break the test code. So Mocha can be installed as a dev dependency using the following command. So this is on our server side Node application. We can do an npm install Mocha with the --save-dev, which saves it as a development dependency rather than production dependency. So once Mocha has been installed, we can then set up some test folder locations. So in whatever your project's in, we can create some subfolders for unit tests and integration tests. So the directory structure inside these folders will mimic the application's directory structure. So as an example, rough one here, say we were setting up our project folder and for a unit test, and we have our test.js. So now our test.js, the basic sort of run through to creating a test. And we'll talk about this line here of assert. We'll talk about assertion library shortly. But we need to describe, so this is just a text line here describing what the test is about. And then the it statement is saying that this should return, and the language used here is specific to the assertion library that we're going to be using, but we should return a -1, so this is describing what the it was, when the value is not present. So this will return either a true or false. So the callback on this is we're asserting that 1, 2, and 3 as an array, and the index of at 4 was -1. And similarly here. So these will be returning either a true or false. As a general thing that I've read is that the arrow functions or the lambda functions are sort of discouraged in Mocha. They change the base context of this within the function. So they would prefer to use the standard callback function using a function rather than a lambda or arrow function. So to run a test from your npm command line. So with npm, we can run tests from the CLI. So to do this, we need to add the tests to the scripts section of your package.json. So you'll find that in the root level of your server application. And what you'll find here is if you want to run your tests, actually, yep. So if we wanted to run, say, a unit test, we would end up running npm test or run script tests to run those particular tests. So formatting Mocha for an integration test. So back here, this one we're looking at is doing a unit test. So you'll notice here there is no setup, no breakdown for these particular test cases. We have our test or a group of tests here being described, and then we have what this test is meant to do and what the assertion for that test is. Then we have another name of what this test should do and what the result should be. You notice here that in this example we used the lambda functions. We shouldn't use those. Should use the standard function description for those. For an integration test, we have some stuff here extra, of a before and an after. So this is where we can do our setup and our cleanup at the end, so that we'll have our test. We can do a range of things that might set up a connection to a dummy database. We might set up a connection to a mocked up API call and create some dummy information which would then be passed into our test. Your test will assert whether it was true or not, and then afterwards we can reset that information so that if you go to run the test again, we're ready to go again. So the first describe block that we saw in here is used to identify a single test. The child describe blocks, so the child describe blocks, are used to identify a single test case. Note that each child describe block has a before and after function. So that before and after function is used for the setup and the cleanup. So the before function is called before the it block is called, and should be used to set up any database requirements, etc. that the test may require to be run. The after function is used to clean up any database changes made before the next test. The done callback in the before and after functions is used to tell the it block that the setup or cleanup has been finished. So I mentioned before assertion libraries. So assertion libraries allow us, Node has its own assertion library called assert that we can use. And basically it's just stuff that will return true or false. Is this number greater than this? Is it less than this? Is it equal to this? And there are a number of different assertion libraries available. So there's the language of them is different in how they assert what they do. That we should have an expect, a should, and a accept. And the chai library here has all three of those built into them, but there are a range of libraries that we can use for this.